name is Scott Shapiro. I'm General Counsel for the Flood Control Association, and I'm pleased to be your moderator today. I'm going to provide an introduction for Dr. Daniel Swain as he plugs in the last of his cables. Hopefully you've noticed the pamphlet on the table, which has detailed information in it, but if not, I'll at least read one sentence. Daniel holds joint appointments as a research scientist within UCLA's Institute of the Environment and Sustainability, which I just learned is actually in Boulder, Colorado, a research fellow at the Capacity Center for Climate and Weather Extremes of the National Center for Atmospheric Research, and as the California Climate Fellow at the Nature Conservancy. When I emailed him to set up our last call, I got an email back that said something like, "It's very busy now in California. We're having a lot of events. If you're calling for interviews, please get in the queue. If it's important, I'll get back to you within 24 hours. And he did get back to us within 24 hours. So one of the most popular people out there right now, and everyone wants to talk to him. Present to you Dr. Daniel Swain for our keynote address.
Thanks again for the introduction and for the invitation to speak here today to this audience. You know, when we set this up, we had no idea what was going to transpire this winter in California, since we had these conversations late last year initially. So it's been a bit of a wild ride, obviously, in the few months since then. And I'm going to talk about sort of how that looks in the context of what's coming down the pike. So just to, I think you already got this content, but just to emphasize that I wear a few different hats in the Institute of the Environment and Sustainability at UCLA, which is in fact located in Los Angeles, but the National Center for Atmospheric Research, which is in fact located in Boulder, Colorado, is another one of those hats, as well as the Nature Conservancy. So these sort of unusual arrangement, public-private, and then something that's sort of in between public and private allows me to do a lot of the things that I do that aren't just research. So have conversations with different audiences, interact with the media, do this public engagement, science communication, in, with a real focus that is difficult to do if you don't have some real support for that. So I just wanted to acknowledge that before diving in to some climatology of California 101. And some of this probably goes without saying to this audience, but I do think it's interesting to just see the visuals anyway. California has sort of this unique climate in the context of the rest of the United States, certainly, but also in the context really globally, and especially in North American context, where there is an unusually high degree of variation of hydroclimate and precipitation across a range of timescales. So we often think about this variation as being from year to year. So we have some really wet years like this one, and we have some really dry years like many of the years we've seen in the past decade. But this also is true on different timescales. So we have an unusually high degree of variability from season to season. It's actually not that common in North America to have a really distinct dry period in the warm months and a really distinct wet period in the winter months. Folks who have lived elsewhere probably realize this intuitively. But in California, this results in a few challenges, because it means that we have not only this kind of chaotic year-to-year variability, but we also have this very well-defined season-to-season variability. And the practical implication of that is that we are very susceptible to both drought and flood, because we really only have a narrow window in which we can receive all the benefits of the water that we need to get to do what we need to do with water during the winter months. And if something comes along, say a persistent ridge of high pressure that deflects the storm track, as we've seen repeatedly in recent years, then we're kind of out of luck, because we're not going to make up those deficits in the spring, summer, or fall. We're going to have to wait at a minimum until the following winter, and if we're unlucky, multiple winters in the future. So it's easy to fall into deep droughts here for that reason, but it also means, because we get such a substantial amount of precipitation concentrated into the winter months, that makes us quite susceptible to water overabundance as well as scarcity, because we get such a concentrated rainy season. If we have just an extra storm cycle or two crammed in there over the course of a month or two, we can quickly get into trouble with having too much water. And of course, that's more what we're seeing this year. But I just wanted to illustrate, this map on the right shows essentially how unique that variation is in the context of the rest of the United States. California is a very different color than anywhere else in the country, representing its very high degree of variability from year to year compared to other places. And I think in the context, I'm just going to jump right into what the future likely holds, and to tell you that we actually don't really have a good sense of whether California's overall average precipitation might slightly increase or slightly decrease in a warming climate. And I know that surprises a lot of folks I tell that to, but that's just the reality is we don't know, but the changes actually might not be that large, even if we see a lot of warming. But does that mean that hydroclimate doesn't change or that precipitation doesn't change? No, it actually just means that the mean is the wrong value to be looking at. Because what we actually see when we look at these very same predictions that suggest kind of an equivocal or not very large change in mean precipitation, suddenly there's quite strong agreement that the most extreme hydroclimate events become more extreme. So you can imagine if you add an almost equal proportion of very dry events on one end of the spectrum and a proportion of very wet events on the other end of the spectrum, you might actually come out to somewhere close to the same average as you used to have, but you have a very different climate and a very different set of extreme events that you need to be managing. And it also means that only looking at the statistics like annual mean precipitation is going to be pretty misleading. If, in fact, you look at long-term trends in annual average precipitation in California, there isn't much of one, despite the fact we've been dealing with so many record-breaking droughts and now recently severe flooding. All of that's occurred in the context of a climate where the precipitation average hasn't changed that much, which suggests that probably isn't the right metric to be looking at in the first place. The interesting thing about this is that previous slide was referring mainly to year-to-year variability, so more very wet years on the one hand and more very dry years on the other. But this is also true in a seasonal sense. We actually expect California's already very sharply cyclical precipitation climatology, so where we have well-defined wet winters and it's dry in summer and there's some transition season in between, we expect that to become even more amplified. So it does look like we're going to see wetter winters. But again, in the annual average, that's going to be compensated by potentially drier autumns and drier springs. So an even shorter, sharper rainy season to come. And of course, that has significant implications for a lot of reasons. It actually, on the drying ends and the margins, that really ups our autumn wildfire risk. It has implications for snowpack because it means there's likely to become a shorter snow accumulation season and an earlier melting season. This year does not look like that, but I'll talk about that a little bit later. And what it's really going to do is stress out ecosystems and agriculture because it means that the growing season potentially for some things is longer, which I guess is a good thing, but then you're going to require a lot more water to sustain those longer growing seasons amid drier atmospheric conditions during the dry time of year, even though we might be getting more water during our increasingly narrow rainy season. So you can kind of see where I'm going with this. We're sort of getting squeezed at both ends and flailing increasingly wildly from one extreme to another. That's sort of the big picture here. And this is a slide I created last year. I actually could add another panel now on the right with Lake Oroville rapidly filling up again. But just to illustrate how we've gone from a record-breaking drought back in 2014, 2015, to a really extremely wet, record wet winter in some cases in 2016, 2017 in Northern California with all the crisis at Oroville Dam. Then right back to similarly record-breaking drought that would have been the worst drought on record but for the one that happened a few years earlier in California. And you know, what I don't have here is that now we're rapidly swinging back out of that drought and have flood issues again. Fortunately, they aren't aimed at the Feather River watershed this year. They're mainly farther south. But you get the basic idea. You know, we've had these incredible swings in the past decade. Really, over a 10-year period, we've had both the driest years on record and the wettest years on record in some of the same places in California. So this is exactly the kind of increase in what we've called precipitation or hydroclimate whiplash that we've been talking about. So it isn't just focusing on one side of the coin, it's really considering both sides of that hydroclimate coin. And so why is this happening physically? Increasingly use the analogy of the expanding atmospheric sponge. Actually, we did an ABC News segment last year where we literally bought comically oversized sponges for the camera. They were like this big and this big. And this experiment actually works, like literally, it's a little bit too well. Obviously, a larger sponge, as temperatures warm, is going to absorb more water. But that actually means two things. One, obviously, if it's saturated, if you got a big spill of water and you got a larger sponge, great, you can soak up more of that water. So that's representing sort of the increase in the evaporative demand of the atmosphere. That explains the primary reason why we are seeing worse droughts in California and in the Southwest in a warming climate. It's not so much because we're seeing less precipitation, but we're seeing more intensive evaporation. So it's easier for the water that does fall to go back into the atmosphere. But also, obviously, if you wring out that increasingly large sponge and it's saturated, it has the potential, at least, to wring out even more water. And that's sort of the analogy that we think about on the extreme precipitation and the flood side of the spectrum. It raises the ceiling on how intense precipitation can become. And it's important to realize that this is an exponential process. So this is like a compound interest in a bank. It's around 7% per degree centigrade of warming, or about 4% per degree Fahrenheit of warming. And so that literally does compound like interest in a bank. Each degree of warming brings about a larger increase in absolute terms in the atmosphere's capacity to hold water vapor than the last degree of warming. And so that's why I think this process is a little bit counterintuitive. For relatively small amounts of warming, this can exert a fairly substantial effect on the acceleration of the hydrologic cycle on both ends, wet and dry. And so this is why we sort of call it increasing precipitation or increasing hydroclimate whiplash. And although California is a hotspot of it, it's certainly not the only place that's experiencing it. There are different flavors in some places. Some places the wets are increasing more than the dries, or vice versa. But in general, there are a lot of places on Earth where the extremes on opposite ends of the hydroclimate spectrum are increasing simultaneously in ways that I think are really going to complicate water and flood management. And I'm not going to talk too much about drought since this is a flood forum, but I do think it's important to consider, as I mentioned, both ends of the spectrum. And just to reemphasize that precipitation-only drought metrics are becoming increasingly misleading in a warming climate, because obviously you do need to have a low precipitation period to be in a drought, but increasingly it's temperatures driving the amplitude of those droughts. And so, the other thing that can happen is we get more precipitation on fewer days. So you get a temporal concentration of that precipitation. So you have more intensive evaporation, more water leaving the land surface and re-entering the atmosphere. You have more days on which there might be significant evaporation. If you're getting precipitation concentrated into a shorter and shorter rainy season, there just are more days on which there's an opportunity to lose that water back to the atmosphere. This year is not a good example of this, but there is still, even including this year, a trend towards less snowpack. We're still getting these extreme snow years, so we're still getting the really high-end snow years, but we're seeing fewer gentle snow years where we get this nice snowpack that melts exactly when we want it to. And droughts used to be hot drought or cold drought. It was about 50-50 in the 20th century whether droughts co-occurred with unusually warm temperatures or not. Well, it isn't anymore. Pretty much all droughts now are unfolding into in the context of temperatures that are extraordinary relative to what we saw in the 20th century. So essentially the short version of that is all droughts are hot droughts now in most places. All right, so I really want to jump into the core content here, which is, okay, but what about the wet side of the spectrum? We are in this flood forum after all. And I think the main thing that's relevant when it comes to California climate change and flood risk is what is likely to become quite a substantial increase in the intensity and the precipitation generated by atmospheric rivers. I think most of you probably already are familiar with the idea of atmospheric rivers, but just to quickly summarize what they are, they're these narrow filamentary features in the atmosphere. Essentially, it's water vapor moving quickly above your head. So it's water vapor, highly concentrated filaments of water vapor being transported through the atmosphere. And they do really look like, if you look on the top-down view from satellites, they do look an awful lot like rivers in the sky, hence the name. And they can carry as much water as large rivers. In fact, a significant atmospheric river in California might be transporting around 10 to 15 times the amount of water of the Mississippi River, except it's in the form of vapor above your head. So then if you think of it that way, it's no surprise that we get such extreme precipitation events in California when there are these pipelines of moisture that sometimes aim themselves directly at California's mountains, and when that moist air hits the mountains, of course, it's going to squeeze out a lot of water as it ascends and cools and condenses. And so, as I mentioned, the ceiling on how much water vapor can be in the atmosphere increases exponentially with warming. And so given that atmospheric rivers are essentially just water vapor moving quickly, even if the moving quickly part doesn't change very much, but with the water vapor part, the ceiling on that increases significantly, well, there we go. There is where we're likely to see large increases in the intensity of these events, and eventually the emergence of historically unprecedented atmospheric rivers. This is a really robust finding throughout a lot of research at this point, that California is going to see much stronger atmospheric rivers in a warming climate. So just to go back into history, the history that most of people in this room are probably familiar with, although often when I talk to general audiences, very few people have heard of the Great Flood of 1862 in California, which was essentially a month-long or perhaps even months-long deluge that started in late 1861 and continued into the early 1862, in which a historically unprecedented, at least in terms of modern California history, amount of precipitation occurred and resulted in just massive inundation of much of the Central Valley. It turned into an inland sea, perhaps 200 or 300 miles long. Leland Stanford took a rowboat to his inauguration in Sacramento because the floodwaters rose so much between the time when he woke up that morning and when the inauguration ceremony was held. The state capital even, I believe, was temporarily moved to San Francisco because the floodwaters were so persistent in Sacramento at that time. In fact, that event was the motivation for Sacramento to be essentially elevated above its previous elevation prior to this flood. So this was a historically transformative event in California. Of course, back then there were maybe 400,000 or 500,000 people in the state that's now home to around 40 million. So added a few zeros there. Obviously the context in terms of infrastructure population is very different today than it was back then. There's a lot of evidence in the paleoclimate record that the Great Flood of 1862 was no fluke. It was an extreme event, to be sure, but events of that magnitude occur roughly once every century or so in the paleoclimate record. So while it was extreme, and while we haven't experienced anything like it since then, we probably shouldn't be too surprised, even without any climate change, when this eventually happens again, because we know it's possible, because it's happened repeatedly before, perhaps 5 or 6 times in the last millennium. 1862 was the last time. So, of course, a modern day repeat, well, it would be a big problem, given the changed context of a modern California. And previous work that we did a few years ago suggested that there was perhaps a 50-50 risk of an 1862 level flood event in California in the next 40 years from 2018. Not a guarantee, but those are pretty high odds of a very high magnitude event, and that's not a great deal of time. So we often hear about climate projections that go out to 2100, and while it's not that far in the future, it is pretty far in the future relative to planning time horizons at a state level. But 40 years, minus now 5 or 6 years is not that long. This is not that much longer than a home mortgage for a lot of folks these days. So this is in the territory that we really need to be thinking about seriously. It said, okay, well that initial finding really concerned us. I mean, we wanted to say, okay, is this right? What does this really look like if we take the broader view? And that led us to do essentially a new study over the last couple of years. And this is actually an update of something that many of you are probably familiar with, the original arc storm scenario, which is from 2011, was put out, lead agency was the U.S. Geological Survey, but there were a lot of California institutions that were involved with this. And it was inspired by the same folks, in fact it was led by the same folks who I've had the privilege of working with now, who have done things like the Great California Shakeout. So these big natural hazard contingency disaster planning scenarios, and California in an earthquake context is much better prepared than it was 20 or 30 years ago, I think in large part due to these imaginative scenarios that have scared the pants off of some people in some places. And I think that has actually been really constructive when you sort of take the long view and look back over the last few decades. So we said, okay, we probably need to revamp ArcStorm into a 2.0 version, because the 1.0 version did not include anything about climate change in it. It was just entirely based off of historical context, which is important enough. We already know that these things are a hazard, right, in California. We really wanted to hone in on, okay, let's use the latest available science to get a better sense of what we're actually facing. And so when we do this, and actually I'll play this since it's kind of a cool, if alarming animation. This is representing the integrated water vapor transport, the simulation for this physically plausible hypothetical ArcStorm 2.0 scenario. set in a somewhat warmer climate than what we currently have. And as you'll see, this isn't just one big storm. And this loop takes place over the course of 30 days. So this is an intensive month-long sequence of storms that lasts essentially a full 4 weeks. And you can just see that the bright colors that end up in California, they just keep coming, one after the other after the other. And that's this idea that it's not one really big storm that's the primary concern. This is actually something that we've designed the scenario after what flood managers told us, and the DWR emphasizing that it's not the really big one-off ones that we're afraid of. Yes, they're going to cause problems, but in isolation, that's not the big one. The big one is we get a bunch of moderate to strong ones, and then there's an exclamation point at the end, and then we get one really big one then. So it's the sequencing, it's the persistent periods that are the big problems, and so we designed our scenario to accommodate that. And of course, we published this last summer, the initial findings right before this big winter we've just had. Just to contextualize, we sort of had two different scenarios, one that's sort of plausible in the slightly cooler climate that we had the last couple decades, and the other that's plausible in a significantly warmer climate that we might have just a few decades from now. And the differences are quite substantial in terms of just how extreme a plausible worst-case scenario actually is. The historical one is bad enough. It involves 30, 40, even 50 inches of rainfall in a 30-day period in certain parts of the Sierra Nevada. But then, in the future scenario, the warmer climate scenario, we see in some cases a 30 or 40% increase in the plausible 30-day precipitation during those events. And as I'll mention, it's actually worse than it sounds because the runoff increases are a lot larger than the precipitation increases might suggest. And just to contextualize this a bit, I added this because of the winter we've just had. The maximum 30-day statewide precipitation, this is a very rough approximation, so don't hold me to it too strictly, but just as a ballpark, we got about 80% of the way to the lesser, cooler climate historical arc storm scenario. So a good chunk of the way there, but then again, we've gotten that close about 3 or 4 times over the past century. So although it was a big deal, from a statewide precipitation accumulation perspective, it was not something that was unprecedented in our current water infrastructure context. So the infrastructure that did and did not fail this year, mostly did not, well, we've tested it before with events of comparability of this magnitude. Only a few times, but it has happened before. We still haven't seen, in the modern historical context, an event that quite gets even to the lower of these two scenarios. And the events we just saw, again for context relative to the future plausible warmer climate scenario, only about half of the precipitation we would have seen during the same period of time. So imagine taking December through January and doubling it in the same time window. What would the consequences of that have been? What might they be? As I mentioned, it's not just a question of the total volume of precipitation falling, but it's also a question of the phase in which it falls. And by phase, P-H-A-S-E, I mean rain versus snow. And this year, again, we've been fortunate, in addition to the fact that we didn't reach these arc storm levels of actual precipitation, we've also been fortunate, unless you live in the mountains, in which case it's been a terrible winter for digging out and trying to keep your roof from collapsing, these were cold storms. This was a cold winter, certainly by recent standards, and it was even a fairly cold winter by 20th century standards. So a lot of that water, this is why we have now a record snowpack in the southern Sierra, had these been really warm storms repeatedly, this would have been a very different winter. The flood risk would have been a lot higher. And this is one of the big things we see in the future, which is that apples to apples comparison, the snow levels are a lot higher. And it's not so much that results in more rain on snow events, which it might, but that's not the primary concern. The even more basic concern is that even if there's no snow on the ground to melt at a particular elevation, if it's falling as rain instead of snow, that's instantaneously contributing to the storm runoff, rather than being stored in the snowpack and melting at some hopefully more convenient later time. This has really major implications for during storm runoff. So it shifts the runoff curve earlier in the year so that it's more likely to coincide with when we're actually getting these intense storms. So, one of the saving graces this year is that we're heading into April with what could be a very problematic flood situation in the watersheds draining the southern Sierra. But at least we're now starting to get out of the season in which we're likely to see additional big, heavy rainfall events because we're getting into April. But imagine we had this snowpack a couple months ago, and then we got some warm storms. My colleague, Xinying Huang, has termed this the double whammy effect, because what it really means is that, of course, there is this increase in the maximum precipitation intensity, so that obviously it's a big contributor to increased flood risk in a warming climate. But in some places, especially at higher elevations and in places that drain higher elevation watersheds, an even larger effect is this phase change from precipitation primarily falling as snow historically at certain elevations to primarily falling as rain at those same elevations. And so the net effect is that you see a very large increase in the very uppermost plausible tail of runoff curves. And I think these numbers are kind of shocking. I mean, in the sort of this elevation band from 6,500 to 8,200 feet, in a significantly warmer climate, we see runoff changes that are in the order of 300 to 500% higher. Not on average, but the very most extreme values are literally anywhere from about 2 to 5 times what they were in the 20th century. So that gave us pause. So we did this specifically for arc storm, and we've looked at runoff. We're still working with the Department of Water Resources to do the actual flood and inundation modeling for arc storm. We don't have that yet, but these are just straight runoff curves for the Sacramento-based Huck region and the San Joaquin Huck region. And it really just is an indication that in the future arc storm scenario relative to the historical arc storm scenario, they're both bad, but the future one is just kind of blows the historical one out of the water. It's essentially an unprecedented regime in the San Joaquin watersheds in particular, where there's just dramatically more surface runoff during these events, such that on the rightmost plot, you don't even see the historical event on the scale anymore, if we need to scale it so that we can see what the future scenario holds for runoff in the San Joaquin Basin. And this, of course, is a big challenge because that's the part of the state where there is not as much robust flood protection as there is, say, in the Sacramento Basin. So this is happening at exactly where you don't want it to happen relative to the vulnerabilities that presently exist in one region versus another. And although we're talking, I know this audience is focused mainly on river flooding, there's a pretty large increase in the hourly precipitation rates that we see during these scenarios as well. And that's a little bit, I think, a little bit less recognized. This is really going to increase the risk of flash flooding and urban flooding as well. So this is sort of a pluvial flood problem as well as a fluvial flood problem. And it's much easier to fill up those storm drains if you see a lot more individual heavy precipitation hours during these events. And of course, watersheds that have been affected by wildfires, which we're also seeing more of, are particularly vulnerable to high hourly rates during these events. So it isn't just that it's going to be a nice gradual rain that progressively gets more intense, but it really does look like that the intensity of the individual downpours that are going to flood streets and cause problems in urban areas and on small streams, that also looks to be a significant consideration. And so, I do want to point out that one of the reasons why the future scenario is so much worse than the historical plausible worst-case scenarios is because the climate is warmer. And we actually found that lurking in the background, the likelihood of our arc historical events, so our sort of historical era plausible worst-case scenario, which was about 20% larger than what we saw this year, the likelihood of seeing an event like that is probably already doubled due to the warming we've already seen. We're at about 1.1, 1.2 degrees centigrade of global warming. You can kind of see where we were on this chart as of 2022. Definitely an increase in the risk, but nowhere near the increase in the risk that we will see with further warming. And so this, I think, is a sort of a flashing warning light regarding where we're headed right now. And I'm optimistic that we aren't going to get up to the end of this curve. Hopefully we're not on a track towards 3.5 or 4.5 degrees centigrade of global warming, so you can probably maybe ignore that part of the chart for now. But even if we end up, say, around 2 degrees or 2.5 degrees of global warming, as is in a lot of these global targets that we may or may not hit, depending on policies in the coming 10 or 20 years, that's another doubling of the risk from today over that period, if not more. And so this is really something that we're going to have to grapple with. You can imagine that these are low probability but high consequence events. And so if an event that had an annual likelihood of about 1%, say a 100-year recurrence interval, and you double it, well now that's a 1 in a 50-year, 2% event. double it again, and now that's you know, a 4%, so 1 in 25 years. So we've gone from something that might have been a once-in-a-century event that a good chance that most of us wouldn't live to see, to being something that most of us would experience at least twice in our lifetime. That's a pretty huge change in the risk. And we did find, sort of updating that earlier number where I mentioned there was about a 50-50 chance of an 1862 level event. Well, this is a similar finding, that a slightly lesser event, the arc historical level event, we found this is about a 2 in 3 chance of occurring between about now and 2060. So these are essentially similar kind of statement about an event that's slightly less extreme, but also more likely. And I think I threw this in here because it's a little bit technical, but I think it's relevant in the context of a year. This year is very wet, of course. We're experiencing lots of flooding. But we went into this from a severe drought, which has turned out to be kind of fortuitous because it helped us. Our initial reservoir levels were low, soils were dry, rivers were running low. There was a fair bit of capacity to absorb the water in the systems we've got. But what if this had been, what if last year had also been really wet, and then we saw this winter? Well, that might be the pattern we're setting up for this next winter, because there's a strong indication that we're headed for potentially a significant El Nino event. So stay tuned for that. Ask me again this summer exactly what this means. But in our research, what we found, at least in the physically based modeling world, nearly all of the most plausible mega flood events in California occur during moderate to strong El Nino years. So although El Nino is not a great predictor of average precipitation in California, it is still, we believe, a very useful indicator of which years are the most likely to cause big problems. We're going to miss some years. This year is not an El Nino year, and we really did miss this one. So this is never going to be a slam dunk. But in this context, this is something that might help us out, because we can predict El Nino and La Nina at least a few months in advance. So would this be at least give us a tilt in the odds, a sense of which years are most likely to be a problem? Stay tuned for 2022, 2023, because things are already really wet out there, and we're going to have residual soil moisture in the mountains watersheds all the way through the summer. So this could be setting us up for a challenging year next year, but again, let's revisit that this summer. But I think the optimistic view there is that there actually might be some predictability, not exactly which year it's going to occur, not exactly which month it's going to occur, but we might be able to suss out which years are more likely to feature an event like this, which could give us an edge, I think. All right, so this it probably took a little bit longer than I wanted to in some earlier slides, so I might go through this one quickly. So I want to talk a little bit about some solutions, not just doom and gloom. But I do think that I want to emphasize that California is actually a climate change flood risk hotspot. We're currently sitting in one of the most flood vulnerable cities in North America, and that's true without climate change. With climate change, that's likely to become more true, not less. I think that's important to recognize. And one of the things we want to know, is California's flood control and water management infrastructure up to the challenge? I mean, what would this look like when we truly stress test the system under conditions that we have not seen in the 20th century, but we know are possible because they've happened before the 20th century. They happened in 1862 and roughly 5 or 6 times per millennium before that. So we don't even have to really be talking about climate change to want to know the answer to this question. And it's not just a question of fluvial flooding, but also a question of, especially if we do see increases in the intensity of hourly rain rates and things like that, what about urban flooding? What about storm drains? What about the ability to remove water from highly populated areas, even if the levees hold? That's an entirely different challenge. And so we really do need to be thinking about, low probability but high consequence events. And so, what would this look like? And I'm deliberately using language like California's, quote, other big one. That's actually not my descriptor. That actually comes from, I believe, Lucy Jones, who is more versed in the original big one, which is a high magnitude earthquake somewhere near Los Angeles or San Francisco, which would of course be very bad. But it's also different because those disasters are regional disasters, where if there's a big earthquake in LA, well, fortunately, Sacramento and San Francisco are still going to be operational and can help out. In the big flood scenario, that's not necessarily true. This is a statewide event that might actually also affect adjacent states, and so it would be an event of a very different variety, a disaster on a different order than the other kinds of events which we're used to, which are usually either local or regional. Wildfires, earthquakes, they tend not to be occurring literally everywhere all at once, but that might be the case during one of these really severe flood scenarios. And California's water and flood protection, of course, was built for a 20th century climate that no longer exists. That's not an indictment of the engineering, it's just a statement of reality that you can only design structures for the conditions that you believe are plausible. And the conditions that are plausible have changed since when these systems were designed and built. And so this is something we're trying to get at in ArcStorm, the later phases of the project that we're still working through. So our initial results have come out, but we're still working with the Department of Water Resources and other agencies to really use this, I hesitate to use the term war game, but that's kind of what it is. It's really truly stress testing the system under something that is not the worst possible event, by the way. There could be even larger events, but what we really want to do is say, okay, what is a plausible worst case? We're not saying like, what happens if there's a 10.0 on the San Andreas Fault? And saying, well, it's a bad day, but let's deal with things that we can actually think are plausible to happen in our lifetime, and that's what we're doing with ArcStorm 2.0. So we're deliberately not choosing the very most extreme plausible events, but we're dialing it down a tad to say, okay, what happens with the events that we would be unlikely but are definitely not implausible if we get unlucky in the next few decades. The original ArcStorm scenario, and this is not our findings, but these are the findings from the original event, if you do the inflationary conversion to 2022 or 2023 dollars, was thought that that scenario could produce essentially $1 trillion in losses, trillion with a T. I believe that would make it the most expensive disaster anywhere ever, at least to present. I'm not an economist, but I suspect that our numbers are going to look similar. So these are really massive events. But the reason I bring that up is because then the question is, okay, so how much money does it make to spend to avert some of these costs? And you're never going to be able to avert all of the costs, of course. But if we're talking about the potential for trillion with a T dollar losses, then multi-billion dollar expenditures to address the problem starts to sound like a pretty good benefit to cost ratio in that context. The other context is that, I'm deliberately not talking about lives lost here because I think it's not super helpful to speculate. I've spoken with a number of folks in the audience who suggest that the number would be alarmingly high in this kind of scenario. But the other thing is the fact that it would displace millions of people for a long time. So this isn't something that you get out of the way of. You leave for a couple days like a wildfire, and hopefully either it's either burned through or it didn't come through your town. The flooding could be there for weeks to months, and people wouldn't be able to live in their homes for months or even longer in some cases. And that could affect millions of people. We've never really experienced in contemporary United States a time when we need to move millions of people out of a region for weeks to months at a time. Florida's done it, and Gulf Coast states have done it for hurricanes for like a few days at a time, and it's usually a huge mess. What happens if you do this on a semi-long-term or even a permanent basis? I think that's something we need to be thinking about. Transportation corridors, of course, would be a mess. Even this year, they've been a real mess, but they would be more severely and more long-term damage, I think, in this sort of scenario to the point where there might not be an ability to do ground transportation from northern to southern California or from the Great Basin into California, which then brings up the question, okay, how do the airports do? And I've talked to folks at San Francisco International and Oakland and Sacramento, and they would not be faring so well. Some of these would be underwater and not generally operable to general aviation for a prolonged period of time, which brings about an interesting question about how independent California is prepared to be in a scenario like this, which makes it, again, fairly different from an earthquake or wildfire scenario, because you wouldn't have this universality of damage, essentially, in those scenarios. So this is a grand challenge, I think, and this slide is mainly for a different audience. I think everyone knows that then this sort of pits flood control and drought mitigation mandates against each other in a way that I think can be viewed as inherently antithetical, but I actually don't think necessarily is. And so I want to expand on that a little bit. I think what's going to be key, since we're not just talking about increased flood risk, but we're also talking about increased drought risk, and we're also talking about increased pressure just because there's a larger population than there used to be. Agriculture is even more important now than it used to be in California. So there's all of these critically important economic sectors. There's 40 million people here, and the climate is getting not just wetter, not just drier, but both at different times. So how do you manage this? Well, flexibility, I think, is going to be the name of the game. Because the physical reality is both there's an increase in precipitation intensity, but also on the other end of the spectrum in aridity, we have this loss of average snowpack. We still get these huge individual extreme snowfall events with more intense runoff resulting from them. Can we mitigate these risks of drought and flood, of water overabundance and scarcity, respectively? Can we mitigate them simultaneously? Are there ways to do this in a way that's complementary? And I think it's becoming really clear that the historical management paradigms probably aren't enough to accommodate some of the changes that we're seeing already and that we expect to see more of in the future. So, one of these is, of course, and I think this is probably obvious to this audience in particular, that we really need to ensure that our quote-unquote hard infrastructure, so our, the levees, the dams, the auxiliary structures on the dams, which seem to be in some cases the weak points rather than the big structures themselves, and urban flood protection, so even things like storm drains and pumps and conduits like that, perform as expected. So the baseline scenario is, okay, is the infrastructure we think we have, is it performing as it's supposed to? That's one question. But then I also think we need to be critically reassessing what levels of protection they actually offer. What does it mean to have 200-year flood protection in an urban area in the context of a climate where, well, the 200-year event historically is probably only the 100-year event now and could be the 50-year event in a few decades. So then what does it mean? Who's defining what that 200-year level of protection is? Is that a moving target? And if so, it's going to mean that we're going, the levee heights and the level of protection are all going to have to be moving targets too. So how do we work with that? Because that's an expensive problem, but it's also an expensive problem to not address when the big one comes. It's also a question of expanding soft infrastructure. To a certain extent, there are some flood events where we're just going to have to let the water do its thing, and hopefully it's in a semi-controlled way versus a fully uncontrolled way. And so there are things like levee setbacks, river bypasses, floodplain restoration. I have joint appointments with the Environmental Institute at UCLA, with the Nature Conservancy, and there are groups that work a lot on this and have had some successes. But the reality is, I think we need to be thinking bigger, larger in spatial and temporal scales for these kinds of projects to really be commensurate with the scale of the challenge at hand. And then, of course, there's how do you operate your existing infrastructure more effectively. And I think there's a lot of promise in things like flood-informed reservoir operations. I really hope that continues to expand throughout California's infrastructure. It's something that's been pioneered by DWR and the Scripps Institute down in San Diego. And really, I think that that's incredibly important work. I think we'll continue to get incrementally better forecasts, and we'll be able to operate dams and auxiliary structures in a smarter way that both averts releasing too much water, and we don't want to lose it, but also maintains safety margins for flood pools. Because the arc storm isn't going to come completely out of thin air, right? It's not just going to wake up one morning and there's going to be water on your doorstep. We will have a significant amount of warning, at least on the order of days. So there are things, we can retool infrastructure to be risk averse, but also in a way that accommodates risks on opposite ends of the spectrum simultaneously. There's also managed aquifer recharge. We probably need to be storing more water underground because we actually, if you think about it, the aquifers are far larger than any reservoir you're ever going to build. And it also means that you can maintain larger flood pools, potentially, if you need them in the reservoirs, because you're not so worried about releasing that water and then not having enough during the inevitable drought to follow. If you bank more and more of that underground, you give yourself more breathing room when the floods come. You don't have to be as reactive and release all that water as soon. And then I think there's a question of improving just awareness, both at the agency level and on the public side. And so this is where I think our tabletop disaster exercises, in improving these data visualizations, like really looking at okay, instead of just saying a boring time series chart, what would the atmospheric rivers look like in motion? If you were looking at a weather model, if you were looking at a satellite map when this actually happened, let's emulate that, and that's sort of part of what you've seen today. And this slide, I added in at the last minute after conversations with the organizing committee for the Flood Forum, because I think that this is, in this audience, I think most folks are very sensitive to the practical realities of talking about big, bad things. and putting them in the proper context, realizing that you have to be really thoughtful about how you talk about these kinds of things. The reality is that much worse events than we've experienced from a flood perspective in the 20th century California were already possible. So let's ignore climate change for a moment. This was already something that could have happened in the 20th century, but didn't. So in that sense, we got lucky. But that also means the 20th century isn't really a very good guide for what was possible even in the 20th century climate in California. So I think in a certain sense, we've gotten lucky and been a little bit lulled into a false sense of security there, because we just haven't had to experience the very high magnitude events that occur 5-6 times per millennium in a modern California context. For most floods, right, reliable and well-operated infrastructure is critically important and helps greatly. This year has been a good example of a pretty extreme sequence of meteorological events that, although there obviously has been major flooding in some places, on a statewide level and in terms of major population centers, infrastructure has done a good job protecting a lot of people in a year like this one. So there's a huge amount of value in that. And so I think making sure these systems are in as good of shape as they can be and continually upgrading them is important. So there's still plenty of work to be done there, and there's lots of reason to do it. But I do think we need to be thinking about the kinds of scenarios that would exceed even well-built and well-operated infrastructure, because what we're seeing on the climate science side of things is that sooner or later we are going to see one of these that just completely overwhelms the system and in which the water is in control. So what do we do about that? When it comes to, and I keep coming back to this notion of the big one, because we've done that with earthquakes. Most of California cities have now done a lot of work to prepare for events that are way larger than anything that they've experienced. So we have experience of the Northridge earthquake in Southern California and the Loma Prieta earthquake in the Bay Area. Those were big events, and they were bad for a lot of people. They killed people, they collapsed buildings, but they were not the big ones. There are much larger and much worse plausible earthquakes in the Bay Area and in LA. And scientifically, that's been recognized by seismologists and solar geophysicists forever. But for a long time, cities were kind of in denial about this, saying like, well, we'll prepare for the big ones that we've seen. Those are the biggest things we could get, right? They were terrible. And the geologists said, no, you should really be thinking bigger. That's, I think, what we need to be doing when it comes to the risk of flooding in California. Because I think the earthquake is a good model because it's largely a successful model. I think it's, we haven't tested it yet, and hopefully it's a long time before we do. But I think California and its major cities will fare much better today than they would have in the 1970s and 1980s if we had that magnitude 7.5 earthquake in San Francisco in that period. If we had a repeat of 1906 in a modern context, we're in better shape today than we would have been 30 years ago, for example. And so I think that that's where we need to be going with the risk of a mega flood. But how do we do that? And I think because the challenge is in that kind of setting, the focus becomes less trying to mitigate damage and more just trying to get people out of the way. It's life protection, right? So how do you do that at scale? It's challenging because there are a lot of people in California, millions of people in California today live in major floodplains. This is something that there's been a huge amount of development in a lot of the Central Valley cities, but also in non-Central Valley cities. We're even talking about the coast or the bayside in the San Francisco area. We're talking about the watersheds in Los Angeles and Orange counties, which are quite flood vulnerable as well. So this is definitely a Central Valley problem, perhaps even primarily, but certainly not solely, and I think that there's more risk in other places where even on smaller but flashier watersheds than we've been thinking about. And of course, that's a slightly different management challenge, but in general, the focus is the same. For a big enough event, you're not necessarily trying to prevent damage, you're just trying to prevent loss of life, primarily. So, I know this is probably a lot, but I think it's, I'm deliberately saying some slightly provocative things, I think, because I think it's important to be thinking differently about flood risk than we've visualized drought and wildfire and earthquakes, because they are not symmetric hazards. And the 20th century, as I mentioned, is not a sufficiently good guide of what's physically plausible. And again, this is not only a climate change statement, this is just a statement about the Earth history that we know from river sediment records and lake deposits. We can see these huge flood deposits. We know they've happened before, and we know that they can happen again. We do find, though, that climate change has already increased latently and kind of quietly in the background, because of course we haven't experienced one of these events recently. But of course, if they've gone from being a once-in-a-century event to a once-in-a-50-year event, you wouldn't necessarily expect to experience them over the course of any given decade or so. And this is all in the context of increasing hydroclimate whiplash. So it's not only an increase in flood risk, but it is also an increase in drought risk. But I do think that we've focused a lot on drought in recent years, and I do think that flood risk looms large because perhaps we just haven't had as much recent experience with it. This year, of course, is giving us a taste, but in the future, there will be more where that came from. So as I mentioned, ArcStorm 2.0 is designed at sort of addressing some of these things. We have some initial results out now that you can read, you've probably already seen in the news, but there's more to come, and we're working with different state agencies to really transform this into a tabletop disaster management exercise and to really bring some new flood modeling capacity in-house at DWR so that we have the ability to do this in real time if and when the big one does show up in the 2-week outlook at some point. And there is a lot that can be done. I mean, I think this is none of this is a foregone conclusion. I mean, it's a matter, of course, of hardening our hard infrastructure and expanding our soft infrastructure, finding ways to let the water do its thing, and in sufficiently big events, finding ways for things to fail gracefully. I think that's a principle that a lot of engineers in the room are familiar with. And I think that's going to be just increasingly important. The flexibility that we have inherent in the system, I think, is good, but we need more flexibility moving forward because, as I mentioned, our whiplash, we already live in a whiplashy climate, but that's only going to increase as temperatures warm. And, flood and water managers are really on the front lines of all of this. I mean, I think there's a lot of folks who live blissfully unaware of what happens behind the scenes in California and elsewhere, but especially in California, where this really is a significant operation, at various levels, from private entities, government entities at all levels of government, from local to federal. This is a huge operation in California that's only going to become more important and more challenging. The proverb, "May you live in interesting times," I think, certainly applies here. So you'll never be out of a job, but I think there's going to be some stressful periods. So with that, I think I'll close on a cartoon from KQED on the basis of our 2018 paper. But I think this sort of summarizes, I think, how a lot of us are feeling. Certainly how I feel about doing research into these big bad things, but also really wanting to move beyond just talking about the problem and talking about things we can do to improve outcomes and reduce how much harm would actually occur from the big things when they do inevitably occur, as we do live on a planet with a lot of variability. So with that, I think it's probably time, I don't know if we have time for individual questions or if it's the panels next, but thank you.
I think we'll bring the panel up and we'll do questions at the end as part of a half-an-hour Q&A. Okay. So we can just leave that there. It's an entertaining background.
Yeah. I'll move it over here.
Oh, I'll just move the
okay.
I don't think we ever did a flood tabletop. Scott last night.
Yeah, we're going to do about a 5-minute break here if anyone needs to use bathrooms or get coffee. I know many of you have questions for Dr. Swain, but we're going to do a panel conversation first. It may answer some questions or it may create other ones for you. So we agreed we're going to start off with about 3 minutes for each of the panelists to share a little bit of perspective of who they are or what's in their heads, maybe before they heard this or maybe as a result of what they heard. And we're just going to go down the line and do that. We're going to start with Keely Bosler, who's the newest member of the Central Valley Flood Protection Board and brings a unique perspective today because of her time as the Director of Finance for the state of California. Keely?
Good morning.
He's going to turn it up over there. It's on. It shows green.
All right, good morning. My name's Keely Bosler, and it's just a real pleasure to be here with all of you today. Like Scott said, just was recently the finance director for Governor Gavin Newsom over the last 4 years through the pandemic. Was not a fun job, but I'm really excited to be able to spend some of my time now post-state government working with all of the great people on the flood board and all of the staff, and really focus and deep dive issues and bring my knowledge and about the state financing system and some about the federal system as well to really bring more attention and resources to this issue. And obviously what we just heard is a huge motivator and also really demonstrates how far we still have to go. I had the daunting kind of experience of just joining the flood board a month before our new plan was adopted. But I have to say I've been through it forwards and backwards now, and I'm really impressed with the work that's been done by our staff at the flood board and also Department of Water Resources. I think it's a really unique plan because it really lays out the vision and what needs to be done, including very detailed information about metrics and about things that we need to achieve. And the most exciting part to me, though, is the part about the regions. And because that's where you see the really specific projects. So how we translate this big planning process that's at the state's level for the Central Valley down into the day-to-day work that you all are involved in and the projects that you're building in your regions, I think is a really, really powerful thing. And it's something that we, can really, with more of that local regional planning, we can really accelerate and make sure that we're addressing all of the things that Dr. Swain just warned us about for the coming century. And it's really important. That's one of the things that when I joined the board, and people were like, oh, why are you doing that, Keely? Because you've worked on all these different areas. And I said, you know what, I think this is really, really important. It's about protecting people and infrastructure. And just really excited to be a part of that and to help raise awareness of the issues and get some things done. Accelerate our progress is really what Dr. Swain's presentation really calls for. And so that's what I'd like to work on. But just a little bit about the flood plan, if you aren't aware about it. It's got some really kind of daunting numbers in it about what's needed. And that's really important right now because the governor clearly has called for a resources bond that would be before voters in 2024. That's something that flood really needs to be a part of. The plan clearly calls for around $3 billion for the next few years, of course, re-upping that in 3 to 5 years as well. But the things that I think are more challenging are the O&M and also the deferred maintenance costs. These are ongoing gaps on deferred maintenance. The need is 8 times greater than what the investments have been historically. This is probably not a newsflash to all of you. The state has piles of deferred maintenance across all of its infrastructure categories, and so flood is just one of them. I'd say, personally, I think it's a really consequential one. But the O&M is also, the need is 2 times greater. And so these are things that we're going to have to continue to work with the governor, with the Department of Finance, and with the legislature to make progress on so that we can check off that one, making sure our hard infrastructure works. But in terms of some of the things that I'm going to get really excited about are those multi-benefit, is what we call them. I think, Daniel, you had a different term today, flexible adaptations. I think those projects are really, really important as we think about how to relieve the pressure in the system. And when I look at what money has been allocated by the state, and I know I'm over 3 minutes, I'm so sorry about that. I think about how we can deploy that money to have multiple wins. So I don't want to just look at the money that's coming through Department of Water Resources and very clearly flood, but also looking at the Department of Conservation, where they have money for ag land conservation, looking at fish and wildlife grants for ecosystem restoration. How can we braid those monies together to put together projects that also have flood risk reduction as well? So those are some of the things that I'm excited to be a part of.
Thank you. Thanks, Keely.
I just happen to have my own microphone. Thank you very much. I am.
Let me just introduce you so that folks know. Roger Nielo is a senator representing the Sacramento area. Formerly was in the Assembly, County Board of Supervisors, but also brings a unique perspective, having been CEO of the Sacramento Metro Chamber for a number of years, coordinating activities of our local businesses and our local governments.
And friendly local car dealer.
You'd have to pay me to say that, though.
I'm taking the $5 back that I gave you. I have been involved in water management issues for a few decades, actually. I advocated for flood control, specifically additional detention on the American River. That's code for the Auburn Dam, which is not a project that has too much life at this point. But also I participated in the water forum. I'm sure that there are some people here who know of the water forum in the Sacramento region during the 90s, which came to agreements for water conveyance that had otherwise been sort of stopped in gridlock in the late 80s. I'm the joint author with Susan Eggman on SB 638, which I will call a sort of a down payment maybe on the issues that Keely was just talking about. Their flood protection board stated needed investment of $25 to $30 billion, and this bond is a $6 billion bond, so we will still have a way to go. Just very briefly, it's $2.5 billion set aside for the Central Valley flood control system, plus other set-asides for non-federal costs in other areas, components of multi-benefit projects, which Keely mentioned, and safety projects for existing dams. It has passed the Natural Resources and Water Committee, but it's a work in process. There have been amendments suggested by that staff, and so the bill will continue to work through the process, but might change a little bit. So, but this is a long-term process, as our speaker explained, and this will just be one step in the continuing work that we'll have to do to protect the Central Valley, San Joaquin more than Sacramento, but let's not forget the Sacramento Valley, because those watersheds will be threatened by those extreme events also. We have some time, but not a lot of time, and need a lot of resources toward it, so we'll continue to work on that.
Thank you, Roger. Next up is Lori Najura, and Lori is the Deputy Director of Planning, Preparedness, and Prevention with the Governor's Office of Emergency Services.
Thank you. Thank you for having me here today, and amongst these very esteemed panelists. As the disaster planner for the state of California, there's a lot of things that keep me up at night, and thank you, David. Now I have a few more. At Cal OES, we do statewide planning, so we have the State of California Emergency Plan. That's kind of the framework for emergency response here in California. But we also do catastrophic planning. We have 3 event-based scenarios. Those are our earthquakes in Cascadia, Subduction Zone, Bay Area, and Southern California. And then we have the one weather-based catastrophic plan, which is our Northern California Catastrophic Flood Response Plan. And it is based off of some older maps, some federal National Flood Insurance Program mapping. We have considered about changing our assumptions and moving more to an ARC Storm 2.0 basis. That's some planning updates that we'll probably be doing in the near future. Also at Cal OES, we have the California Specialized Training Institute, and we do the exercising and training for emergency managers and more. But one of the things that Healy and I were talking about just before this is that we haven't done flood-based tabletops. We do a lot of wildfire. We do black sky events, cyber events, things like that. But this was one that was already on our list of things to do before these winter storms, so obviously very fresh in our minds. But that is not why I was invited to speak on this panel. At Cal OES, we also do hazard mitigation planning, and we administer hazard mitigation funding. We've got a couple main funding sources that I wanted to let you know about if you don't already, so that you can avail yourselves of them. It doesn't have the impact. I've been eclipsed here with billion-dollar bond funds, but we do have hundreds of millions of dollars available for mitigation projects. We do administer the Federal Flood Mitigation Assistance Program at Cal OES. Now, the state of California actually gets a very, very small share of the nation's percentage, and that is because it's based on properties and communities that are already under the National Flood Insurance Program. That's not highly widespread here in the state of California, but for that program, local governments, cities, townships, counties, special district governments, and tribal governments are considered eligible sub-applicants through Cal OES, although tribes can go directly to the federal agency and apply directly. As I said before, you have to participate in the National Flood Insurance Program, not be withdrawn or on probation or suspended, and the structures identified in your sub-application must have an NFIP policy in effect at the time of the application, as well as for the life of the structure that has been mitigated. So there's more information about the NFIP on FEMA's website and on the Cal OES website if you want to look more into the Flood Mitigation Assistance Program. You can go to our website. I'll give it to you in just a moment. But we do have a couple projects right now that have been awarded flood mitigation assistance. Yolo County completed a project in May 2022 to reduce and minimize flooding to the community of Madison. The federal share was $1 million, and that's one thing that I didn't mention, but if you are familiar with these programs, there is a cost shares, and it varies depending on program. It can be 10% that you have to pay, and the feds will meet it 90%. Sometimes it's a 25-75 cost share. We've got 2 FMA projects currently under the way, one in Sacramento County, and that is acquisition of a property that has had repetitive losses due to floods, and one in the city of Davis. That's a pump station and drainage system. Their federal share was almost $200,000 for that latter one. But the bigger program that you're probably more interested in is the Hazard Mitigation Grant Program. And these are dollars that come to the state of California from a presidential disaster declaration. So they could, they're not on say an annual application cycle. It just depends upon when we get those presidential declarations. Guess what? We've got one now. So we'll be a couple months from now, we'll be putting out a notice of intent for the next round of hazard mitigation grant programs. And I think there's actually one open now. These programs, these funding opportunities provide support for communities to implement mitigation activities to reduce risk to life and property. Eligible sub-applicants are state agencies, local governments, special districts, and some private nonprofits. It can be used for local hazard mitigation planning. It can be used for project scoping activities. That's under a kind of a subcategory of advanced assistance. And then I'll share in a moment about, there's a state program called Prepare California Initiative. And it's a one-time infusion of funding, though maybe, you know, if the budget picks up, we can get continuous funding. It provides additional support to cover that local cost share. So for the 75-25 on hazard mitigation, sometimes that 25% that you have to pony up can be pretty intimidating. The Prepare match, if you apply for that state program, it can pay your match. So net $0 to the project. We've had quite a few projects over the past 5 years. I know I'm running out of time, so I won't go into them. Everything from levee repair to water systems, to flood mitigation studies, feasibility studies, you name it. I'll just leave you with this. If you have questions about project scoping or the program itself, you can actually go to hma@caloes.ca.gov. That's an email box that's continually managed. hma@caloes.ca.gov. Submit your questions, you can get more information. You can also go on caloes.ca.gov website and just type in hazard mitigation or type in 404 and this hazard mitigation program will come down. And they'll also lead you to the same page to talk about the Prepare California match. So I'll leave you with that. I'm here if you have more questions about planning, exercising, and these mitigation programs, but honestly, with the panelists here, I have questions that I want to ask. So thank you for your time.
Thank you, Lori. So let's get to it then. So if you think back to the last substantive slide that Daniel had up, he talked about the fact that we're looking at much more frequent large events and then the risk of extraordinary events. And I hope to have a little bit of time to talk today about the extraordinary events, and in particular, some of the work that OES is wanting to do in regard to that. But I'm going to focus most of our time to the more frequent, very large events, because that's the room we have before us, the people who are working in that regard. And one of the things that strikes me is that getting people's attention in this particular topic is hard. Earthquake seems to have more attention, other wildfires has lots of attention, flood is the stepchild of disaster. And so I want to start with a question for you, Daniel. I have noticed that you have a very strong social media presence. And flood is not something that I've typically seen having a social media presence. And so I'd love to get just your thoughts on how you've created that and whether it's working, whether it's achieving what you thought. Are people actually understanding risk as a result of what you're doing? Or is it more, okay, I guess we shouldn't have the softball game this weekend?
Yeah, I think we need to get turned on still. Power's on. Testing. Great. I think this is an important one because, you know, a lot of this comes down to, I guess you could call it, a lack of imagination in some ways. I think with wildfire, imagine where we were a decade ago. You know, it's 2010, 2012, around there. And wildfires have been a staple of California reality, you know, for as long as California has existed, and even before California existed as a state, of course. However, you know, the public view of wildfire was, for the most part, unless you lived in a really high fire risk canyon in suburban Southern California, or unless you were in the middle of a dense forest somewhere, you was really out of sight and out of mind. You might have some smoky days, you might see a fire in the distance when you're driving on the freeway, but it was not a really substantial part of daily life for most Californians, I think. And so it was sort of out of sight and out of mind. And then enter the last decade. That is completely different now, where everybody in California's lives were substantially affected by fires. Even if you lived in the middle of San Francisco, you had these Blade Runner orange skies and days where you couldn't safely go outside. So the public opinion on fire and the perception of the relative risks that are posed in this part of the world dramatically shifted due to real-world events in the past decade. We will eventually have that decade for flood in California. We haven't yet had it. And so I hope that we can implement some of the positive changes we're talking about today before we have that equivalent decade for flood in California. We don't know when it's coming. We could already have entered it with this year, or it might not happen for 40 or 50 years, but the odds are going up. I think the challenge is that there is this recency bias. There's actually some interesting research, like academic research using Twitter for the remarkability of heat waves. So essentially what this is actually led by my colleague Francis Moore at UC Davis, where I'm headed later today, but the basic idea is that even though temperatures today would have been just extraordinarily unprecedented in many cases for most of the 20th century, and therefore for most of the life experience for most of the people alive today, we don't really perceive it as such. And this is literally data derived from how people are talking about it on social media. So we really only notice deviations from the last 3 to 5 years. If it's extreme relative to 50 years ago or even 20 years ago, nobody can tell. If it's extreme relative to the last few years, people tend to notice. So with temperatures, we just have this incrementally increasing baseline. I think it's harder, eventually you start to get used to it. With flood and water, though, California just has such extreme variability year to year, and it isn't just a monotonic shift in one direction towards drier or wetter, that I think it's harder. I think that maybe is why it's so difficult to conceptualize, why it has a different, people feel differently towards flood than toward wildfires or earthquakes. And I guess this is a roundabout way of saying, I don't know how successful we've been, but that is part of the reason why we have created this ArcStorm 2.0 scenario, why we've revamped it, and why we've unrolled it publicly in the way that we have, where it really did get a lot of media attention. Some accurate, some not so accurate, some quite exaggerated, and some perhaps actually understated. So you get the usual range there. But I hope it's starting to shift the conversation. I think this year's events, even though they were not that extreme in the context of what we're talking about, will hopefully move the needle in terms of public opinion and the way we're thinking about it, because it's sort of, I guess fortuitously, comes right after this window where we've talked a lot about the really big ones, and then we just experienced a big but not that big one. Hopefully this is sort of baby steps towards better public knowledge.
Thank you, Daniel. Healy, I want you to follow up on that. You came from a position within California government as Cabinet Secretary, Department of Finance Director, where you had to be an expert in everything but about this deep, right? And now you go to sleep carrying your centralized flood protection plan, right? Jane Dolan insists that all the board members carry it. And so you are reading it and learning in depth. And we're curious about your perspective going from this deep to this deep. What have you learned? What do you realize we're doing not adequately as a community and educating? Give us some of your evolution learning this and how we can use that to better inform others. I think it just takes a moment for him to turn it up.
No, I think I'm really expert at muting it, is what I think the issue is. I've thought about this a lot, because when I first moved to Sacramento 22 years ago, I was actually really inherently understood the risk, or I learned very quickly that the Central Valley is, and then obviously Katrina happened, and I think that even brought it into the forefront even more, just how high risk this area is. One thing that I just want to kind of go back to one of the things Dr. Swain said that I think was really impactful is thinking about how that hourly rate of precipitation is going to change and how widespread that's going to impact people. I mean, it's one thing to think about these very big flood infrastructure apparatuses that protect a big community like Sacramento, and that seems like very detached from people. and really out of their control, because it is. But I do think these flash streams, that could be much further spread beyond the Central Valley and have really big impacts locally, I think is something that just today really heightened my urgency around this issue. But in terms of, kind of how, this is something that I think that when you're in the positions like the governor is, like Senator Nielo is, there's a lot coming at you from all different issue areas across all of the things that government does to support people. And so it's really hard sometimes to break through as the most urgent thing. What I've really reflected a lot about, how do we position as a state agency within the government, going in front of the agency that I used to lead with the budget proposals, et cetera. And I think it's really being very, very consistent with your message and really staying on track and not trying to reinvent the wheel every few years about what the most important thing is to do. And obviously, I think Dr. Swain today laid out, we've got to make sure that our hard infrastructure is working properly. We've got to invest in a whole lot more of the soft projects, the setbacks, reclaiming land to put water and slow it down and out of the channel. We need to do all of those things, and you all are working on those in your local districts, in your regions, and that's really important. So I actually think this plan, we need to kind of hold it up and say this is our guidebook. This is where we're going, and we're not changing it. Just like sometimes people are changing direction about what the most important thing is to focus on, but just being really consistent with our messages and just not giving up and keep coming back.
Thanks, Keely. Roger, I want to pick up on where Keely was. As you may be aware, the Central Valley Flood Protection Plan, produced by DWR with approval and input by the Central Valley Flood Protection Central Valley Flood Protection Board, has a lot of different inputs to it. But one of the inputs are 6 different regional planning groups. Groups that come together, they sit down, they identify projects, and they put those projects forward as important to the plan. And that regional planning effort has been funded since day one by the state of California. And it's been remarkably successful in actually creating a voice and consistency and having the right people at the table year after year. Unfortunately, the dollars for that are not in this year's governor's budget. And I know DWR is an advocate for it, but you run to a point where dollars are light, and so I guess this year it can make it in. So sitting at the legislature, what advice do you give to these folks about how we engage with the legislature on important issues like this, especially in a year where there isn't enough money to go around? How do we continue to advocate for the general fund funding these important things that are needed to produce the plan to ultimately do the kind of work that Daniel's talking about?
Well, I think we're going to struggle this year, the legislature and the governor, with priority setting. We're all going to have different ideas about priorities, but the fact of the matter is, for the last 5 years, state spending has doubled. That's a 15% compounded increase per year, each and every one of those 5 years, with virtually no inflation and actually negative population growth. So priority setting is not something that this legislature is used to. And there's only about a half a dozen of us, all in the Senate, that lived through a really difficult budget back in 08 and 09. So I think we're going to struggle with this, but just know that we have a fall off in revenues, but the size of the general fund is frankly huge compared to what I was used to when I left the legislature in 2010. We do have money to spend on priorities, and we're going to have to sort of fight it out as to what those priorities are. And with regard to keeping the eye on the real danger with regard to our situation with the wet stuff generally, one of the reasons I think, and I'm going to go a little bit off script on your question, is that we're really used to this being a cycle of sort of unpredictability and a varying between too much and not enough water. It's been, now it's going to be, according to Daniel's talk, and by the way, you have an excellent academic way of presenting it, which is very engaging, but frankly, I think you need to scream and wave your arms a little bit more. And maybe play a little Chicken Little. I moved to Sacramento in 1955, and we lived first in River Park. On Sandberg Drive, our backyard was a levee. That was also the year that Folsom Dam was completed. That year, 55, 56, was a huge storm event. And I remember walking up on the top of that levee and seeing the water at the top of the levee and looking down at the house that I lived in, and the roof was about the level of the top of the levee. So that really impressed me. The Folsom Dam filled up in one season, and it was designed for a level of hydrology that was exceeded not only with that storm, but with half a dozen storms that followed it up to 1987 when we developed the Flood Control Agency here, and then 1997. And in between we had drought years. When there's no rain, you don't think about flooding. And then flooding usually, maybe it's going to be different this time, but usually it happens only one season, and it's you're off, and then you're back into a drought again. So the public mindset on this is difficult to convince, but this is a very high priority, and getting back to the budget, we have to struggle with real priorities of the state.
Lori, I'm going to widen the geographic discussion for a second. I was surprised to find a number of years into my practice that in the Central Valley, the people who speak on flood infrastructure are primarily the reclamation districts and the joint powers agencies that are protecting urban areas. But when you start looking at other parts of California, the Bay Area, the Central Coast, Southern California, you start finding that much of flood protection infrastructure advancement is coming from the county engineers, and from the flood control and water conservation district portions of the county. And that's made it a little bit difficult to connect up advocates here in the Central Valley with advocates elsewhere on this topic. Another disconnect is that until the last few years, I don't think I had any interaction with OES. Right? And I've been practicing in flood for 28 years. We tended to deal with you after the problem, right? And we've been dealing with Department of Water Resources and the Central Valley with the Central Valley Flood Protection Board to solve the problem. Our hope is to solve the problem. We heard today it may not be quite so solvable, but that's still what we're trying for. So, can you talk a little bit about the vision of OES in regard to what we're talking about today, and whether you see a larger role or an earlier role beyond just the grant programs that you mentioned, right? Even that grant program that you got everyone excited about still happens after the declaration, right? It still happens after the President's declaration. So can you talk a little bit about whether OES might be a more regular partner? We figured out how to partner with the Army Corps of Engineers, but we haven't figured out how to partner with FEMA much, and OES is the doorway to FEMA.
That's right, and a lot of what we do is coordination. We bring people together to talk, and in this space, DWR would be the main agency, right? But what DWR needs right now is more information sharing at the local level and up to the state level, so that they can work on those inundation maps, and so that they can work holistically statewide and across regions and what we call branches of the Central Valley. And so in so much as Cal OES can help coordinate that, we're happy to do so. And we can do that through the planning and preparedness. We can do workshops, we can do trainings, we can help facilitate meetings, or just bring us along and we can suggest, hey, have you talked to so-and-so or so-and-so? And we can help facilitate that coordination. That's our ultimate goal here with flood planning and with our mitigation. We're currently in the process of updating our state hazard mitigation plan, which takes a look at the entire state, the risks, and overlays it with vulnerabilities, both with infrastructure and with our populations. And now I think the public comment period actually just closed. Hopefully you've had a chance to look at that, but that framework should be informing both the planning that you're doing and also the conversations that you're having with various communities and regions. What we can do, we can bring the emergency management offices to the table. And historically, they have not been the people that you have on speed dial or that you even think of including in your conversations about planning, about mitigation, and yet they should be front and center. They themselves are doing emergency planning for their jurisdiction, and you need to be included in that. So I think I've probably talked all around your question, Scott, but in so much as we can help coordinate, we want to do that. And then I'd like to hear from you, what can we at Cal OES do maybe to help you more ahead of the disaster?
I think you said something provocative that Keely wants to jump on.
Well, I wanted to actually recount my second month on the job as Governor Brown's cabinet secretary was the day that the Oroville Dam spillway started to crumble before all of our eyes.
And Keely, can I just ask, not everyone knows what the cabinet secretary is.
Okay, so the cabinet secretary, I always see it as really a staff person that works in the governor's office that's really the conduit between the governor and what he wants to accomplish and the government, so over all of the departments and agencies. So that Sunday afternoon, we actually went over to OES's headquarters, which is the State Operations Center, and we actually called in most of the cabinet secretaries to be in part of that emergency response. But quickly we realized that this is a huge coordination effort between parties that didn't necessarily know each other or even understand each other's roles. We had the DWR director, in with the county sheriff. Jane was a part of that in her community because it was impacting her community. The sheriff ended up pulling the trigger on the largest evacuation that I've been involved in, and I think many emergency managers have been involved in, because we just didn't have all the information, and DWR had as much information as they could provide, but it was a really high stress and high risk environment. So I think the bottom line and the point I wanted to kind of reemphasize that there's really a lot of value in having those interactions between flood managers and county folks that are the on the ground emergency response people, including our sheriffs, who often lead those efforts, to really get to know each other when it's not an emergency, so that emergency response can just go as seamless as possible. And actually, one of the things I was really impressed with in the plan is that we do actually say, you've got to get better at emergency response too, which I think is really forward thinking, because I think in the past we've always thought we're going to do everything we can to make sure that the infrastructure doesn't break, and we're still going to do that too, but we also need to be contingency planning, and we need to be able to make sure that people can get out of harm's way if things don't go as planned. And so I would just really encourage all of you to get to know your local county emergency response folks. Make sure that they're as educated about the flood response plans in your area. Make sure you have them. I think some of our areas probably have done less in this area than others. Lori's organization has been leading a lot of efforts to really increase the robustness of emergency planning across the state, but it's something like a lot of county government services that sometimes doesn't get the funding and the support that's needed.
Thank you. I want to make sure we leave some time for questions, so I want to just do one last question for each of you, and then we'll open it up to the floor. So I'd love you to give some advice. You can choose whether it's a local rural reclamation district, or whether it's a sophisticated city with an amazing flood management team. But give one bit of advice for what you would tell them to do in light of what you heard today, or in light of what you said today. Daniel, willing to start off?
Sure. I think that some folks may already be able to guess what I'm going to say here, and I think this is relevant across sort of scales of aggregation and organization. So all the way from the local to the state level and beyond, it's probably aimed a little bit more towards the larger aggregation units because there's just more capacity to do big things, I think, at large scales. But this is not universally true, which is flexibility is the name of the game. And it always really has been in retrospect, but it especially will be in the future. And that means very different things at different scales, right? So at large scales, it might mean large-scale river bypasses and levee setbacks. These are big projects that cost a lot of money and are politically and practically complicated, right? Because you need to figure out how to deal with land acquisition and land use change and zoning, all these sorts of things. But even at local scales, flexibility, I think, is also key. Even if you're an individual landowner and you have land that you don't really want to have it inundated on a regular basis, but it wouldn't be the end of the world. Occasionally it gets wet. Thinking about how to even operate at the individual agricultural parcel scale all the way up to the state level, about how can we make these systems that may exist on my property or in our county or in this state, how do we transform them so that they're more resilient to opposite kinds of extremes, wet and dry, to make it less of a problem when we do have these lurches back and forth from one to the other. So I think that would be my piece of advice.
So I would say actively engage in your regional planning organization, and this is why. Like these projects that are more flexible and adaptable take more, are usually far beyond just your reclamation district. So you really need to kind of have that broader view, really start that conversation, understand different viewpoints on how to slow water down, relieve the pressure on the channel, and really think creatively about how to put projects together. It's going to take some education in a lot of cases with landowners that maybe don't understand all the possibilities, just like Dr. Swain was just talking about. And so I think those conversations are critical. I think that is where we're going to have success. We're not going to have success with state mandates, but we are going to have success with locals coming together to put together really practical and great projects. And so that's my advice.
Well, raise your voice and wave your arms more, maybe. But seriously, strengthening your regional collaborations, as Keely was saying, is important. In the Sacramento area, we formed the Sacramento Area Flood Control Agency after the 1987, if I've got that year correct, event. The Water Forum led to a permanent water forum and also a groundwater management area in Sacramento County, and all of that's been pretty successful here, and those are regional collaborations created out of the realization of the significant challenges of too much and too little water. But for on the state level, your voices in convincing my colleagues in the legislature as to the true risk we're experiencing will be very important. Not just your legislators, but other legislators also. Now, Daniel said that these events are going to affect the whole state, but I think it's more intense in Northern California. Southern California will suffer somewhat too, but because of the Sierra Nevada mountains and intense runoff, it's more than just the rain that's falling on the ground. It's that that's following up in the mountains and draining down as time goes by increasingly quickly. And the majority of votes in the California legislature come from south of the Tehachapies, and they need to be convinced of the true risk of too much and too little water also.
I would say today, as you walk out these doors, you have a call to action. You have learned about the problem. You have a plan. You have groups that meet that have determined projects to mitigate that plan. There is funding to do those projects. And I would also encourage you, when you leave, know you're not alone in this endeavor. You've got here at the table the force of various segments of government and non-government that are here to support you and to provide information and to help the information sharing, the exchange, coordination, if you will. So hopefully this has been very valuable to you, and when you leave, you will be taking with you some actual steps that you can take in the next days and weeks and months. And hopefully we'll have some blue skies for a while so that you can do it in peace, but do it. That's what I would say.
Thank you, Lori. All right, so we have about 20 minutes. We can do some questions. Anyone have a question? Okay. Mr. Bissett, the Sutter Butte Flood Control Agency.
Thank you, Scott. This question is for Dr. Swain. So this year, we've talked about the precipitation that California has experienced. We have like a 300% of above normal snowpack. Precipitation, about 150% here in Sacramento above normal. You said it's not close to the arc storm predictions that you guys are working through, but in advance of flood season, we always have these meetings to see what's the forecast for this coming season. And this year was supposed to be drier than normal. So I'm wondering, based on your experience and your knowledge, how can we do better at forecasting for a seasonal precipitation?
Yeah, that's a really good question, because as you point out, this year, there was really no indication that it was going to be an exceptionally wet winter. That's certainly the case. In fact, if anything, there was a slight tilt in the odds towards a drier than average winter. I think one challenge is with the way that seasonal forecasts are communicated. And a lot of folks will say something like there was a prediction that it was going to be a wet winter. Whereas really, it was a probabilistic statement that there's a higher than usual likelihood of a dry winter, but that any category, wetter than average winter, or dry winter, all were possible, but there was a shift in the sort of the probability curve in the dry direction. So the question is, was this year just one of those really unlucky years where if you had 100 years like this one, would most of them have been dry? That's still possible, that it was actually a good forecast despite not being close to what happened because it was inherently probabilistic. And I think this gets sort of at the heart of science and weather and meteorology and climate communication. It's actually really challenging. But I actually do think there was something else going on this year. I think there was something that was missed. This is just a little bit too persistent, and it's just a little bit too contrary to what the sort of the expectation was most likely for this year. What was it? I don't think anybody knows at this point. One of the speculative things is that it actually has to do with that gigantic volcanic eruption early last year, the Hunga-Tonga eruption, near the country of Tonga, that injected a unprecedented amount of water vapor into the Earth's stratosphere. So this is getting into very technical things, but just to illustrate that there are a lot of different things that can influence the year-to-year variability. And I don't even know if that actually ended up being important for California, but it might have been. We'll find out in a year or two once the studies are run. But I think it comes to show us two things. One is that we're never going to have a perfect prediction. We can never say with certainty, and we'll never be able to. I mean, even 100 years from now, I can say with confidence, we're never going to have a seasonal prediction that says this year will be wet, this year will be dry. We're never going to be there. And there are going to be a lot of years where the most scientifically honest thing to say is we have absolutely no idea it can fall anywhere along the spectrum. That's probably true for more than half of years. But there will also then be some years where there is like, I know the last few years we said we couldn't make a prediction, but this year we're making a pretty specific one. And there are going to be windows of opportunity for that. That's one reason I brought up El Nino. It's not because El Nino and La Nina are incredibly great predictors unto themselves of year-to-year precipitation in California. But if you disaggregate them into the very strongest El Nino events versus the very strongest La Nina events, which are both rare, we don't have a big sample size, those still should be pretty predictive. Those still should give us, particularly in the strong El Nino side of the distribution, should give us some sense that this year is more likely than usual to be wet and probably brings an elevated risk of big flood events. It's never going to be certain, but these are sort of forecasts of opportunity. And I guess the other question is, are there prospects that this gets better in the future, given that it's not very great most years right now, this year being a classic example of that? And the answer is maybe. I hope so. There's a lot of people working on this right now. There's also some private companies working on that right now. We'll see who wins, or if anybody wins. Hopefully someone does. But it's a hard problem. I do think there'll be improvements, and I think what we need to be really focusing on the short term, though, is understanding what these forecasts are, and more importantly, what they aren't when we hear them, and that we should probably trust them more in some years than others, and we really need to get better at communicating which years those are versus the years where it's really just a very minor tilt in the odds versus a major tilt in the odds.
I just want to follow up because this is exactly the conversation I have with my neighbor who happens to be an executive at Department of Water Resources. And this is one of the big issues that the Natural Resources Agency in general has been pushing is more investment in the science so that we as resource managers can do better. And so there has been a major investment at the UCs in California around climate and around climate science. And so I'm hoping that we will make some improvements in the coming years. But it is a huge quandary to be able to operate from year to year without a lot of information that's accurate in the months in the ahead.
All right. Good.
It's a comment, not a question, but after listening to Dr. Daniel Swan's presentation, it's clear that one of these days we are going to get this event where we may not be able to keep the flows in the channel. So there's a potential of overflowing in the American River. So our generation build the spillway and put the slurry walls. I think the next generation start thinking how we harden the land side of the levee so if it's over top, it's not total failure, that it can still withstand to minimize the losses. Just a food for thought. Thank you.
Yeah, I think that gets to this notion of graceful failures. If you know the system is going to not be adequate in a particular context, you want it to fail in a way that is predictable and produces the least bad outcome. And I think that's definitely part of that kind of thinking.
Hi, Daniel. This is for you. I don't really hold much regard for the water year forecast 6 months ahead of time. You might as well flip a coin from what I've seen. But what has happened is the short-term forecasts have improved dramatically. Back in the day when I was operating the reservoirs, maybe 24 hours was considered a good, you could operate based on a 24-hour forecast, maybe 2 days, but that was it. Now, I feel pretty confident with all the information we have, 5 to 7 days in advance, you could operate these reservoirs based on that. And just by extending that time, if we could go from, say, 5 to 7 days to 14 days, the efficiency of the flood system would just dramatically increase if we had a reliable forecast. So I think that's where the focus should be, at least short term, on research.
Yeah, Yeah, and there is a lot of research. Again, sort of Scripps in San Diego is one of the big California institutions that's doing a lot of this. Marty Ralph has led a lot of this research over the years. And you're right, there has been, I think there's been more improvement in short-term forecasts than these seasonal predictions. And I think there is more potential upside. I don't think it's going to happen suddenly, but this continued, slow but steady continued improvement of these short-term forecasts, which has been sustained for decades. I mean, they've just gotten continuously better since the 1970s. Will probably continue for at least a while longer. So that is something I think that is plausible and could be very helpful in managing some of this increased variability.
Yes, hi. Thank you for the presentation. It was fantastic. When I was young and good looking, I started working with the state and I started writing to legislators and Department of Water Resources Control Board, Regional Water Quality Control Board, advocating thousands and thousands of dry dams all over the small tributaries, not even the large ones. And when it fell on deaf ears constantly, so I did not stay that young and that good looking, so I kind of gave up. But I highly believe that small dry dams all over would solve a lot of these problems for real wet years. Thank you.
This table's very curious.
This table. We're on fire. Good morning and thank you to all of the panelists. You all brought a very unique perspective and I truly appreciate it. My name is Virginia Medueno and I am with the Delta Stewardship Council. Just curious, I've been hearing, and obviously everybody's been hearing, about the atmospheric rivers. And somebody told me not too long ago, oh, you know, that term came up about 10 years ago. It really wasn't used that widely. I actually used to work for the Office of Emergency Services at Stanislaus County and worked the flood of 97, 98. And so we would hear about El Nino and La Nina. We never heard about atmospheric rivers. And so my question is the atmospheric rivers, is it the term that is being used more in correlation to what we're seeing with drought and climate change? Or where did this come from? Because everybody's using it. All the meteorologists, everybody in the community, oh, Virginia, tell us more about what you know about these atmospheric rivers. And I said, well, I don't know what the hell they are either. So could you just explain to the layman person what it means? Are we seeing more of it? And is that why the term is constantly being used?
Another good one. If only the audience questions were always this focused. So it's interesting you brought up 97, 98 because the original peer-reviewed literature reference to atmospheric rivers was Zhu and Newell in 1997. So that is the first appearance of the term atmospheric river in the scientific literature. It definitely didn't exist in the public sphere before that, and it took about a decade or so for it to enter common usage after it was introduced in this fairly esoteric academic paper. So the answer is that these are not new. These have probably been around for millions of years. They're actually a pretty fundamental feature of just the Earth's climate system. They actually function to transport water vapor from the subtropics to the subpolar latitudes. It's the main mechanism by which that happens, in fact, all around the world, especially over ocean basins. So the physical process itself is not new. Nothing new under the sun in a certain sense, but that also doesn't mean that they aren't changing. So there's two things that happen. One is that the term has come into common usage. That's definitely true, it didn't used to be there. And at the same time, we're realizing that in a warming climate, because these are nothing but plumes of water vapor moving quickly, if the ceiling on water vapor is increasing exponentially, then these things are going to change. They've been around forever, but it doesn't mean that they aren't going to be different and that we aren't going to have to interact with them differently than we have before. So I think it's both. There's more discussion of it in public, but also the reality is that they are also changing as well.
Because we don't have a lot of opportunities to speak with climatologists, How about bomb cyclone? Where'd that come from?
Believe it or not, and I don't think anyone's going to believe it, that's actually a much older term in meteorology than atmospheric rivers. That dates back to the 1950s, and it is an official meteorological term referring to the physical process of bombogenesis, believe it or not. I think that there were some Air Force meteorologists post-World War II era who were a little bit bomb-obsessed. But it's literally refers to, I actually think that nobody really knows, that probably is the origin story. Military meteorologists really wanted to make something sound like a military term. But the term, it actually has a formal definition of, essentially a low pressure system has to deepen, a non-tropical, extratropical low pressure system has to deepen by 24 millibars in a 24-hour period to qualify as a, quote, bomb cyclone. So there is a very strict quantitative definition, and then we see how this is an interesting object lesson, how that got translated into pop culture and the media. I think a lot of people in California think that bomb cyclone derives from, oh man, that's a bomb cyclone, dude. That's not the origin story. These are like Air Force, very formal meteorologists, but maybe they did have a sense of humor back then. But it's an interesting lesson in how sort of public opinion has shifted and how we sort of appropriated this term to be something different than it was originally intended to be, which was this almost like boring definition, right? It's like particular millibars per 24-hour period, to something that's very evocative. And it's not dissimilar from atmospheric river, I guess, in that it's a term that is a real formal scientific term that has a specifically defined meaning. But in common usage, sometimes it's a little overused or used to talk about situations where it may not give the right sense of what people need to do. Your response to a bomb cyclone isn't the same as a response to an actual bomb, for example. It's not the same thing. And even there, the context matters. Is it close to you, or is it out over the Pacific? If it's a bomb cyclone 1,000 miles from San Francisco, it doesn't matter. We had that once this year. It wasn't one of the bigger storms. If there's a bomb cyclone 100 miles from the Golden Gate Bridge, as happened a couple of weeks ago, then that's a much bigger deal, and we saw a destructive windstorm that really was a historically significant windstorm. So the context matters, and that's often missed in these conversations about these super evocative scientific terms. Even though I think it's helpful to use them because it does increase public awareness of events, but we have to be careful about how that gets interpreted too.
All right, transitioning from bomb cyclones to how we make sure legislation doesn't bomb. Roger, we've got over 100 people in this room. What do you want them to do to help get yours and Susan Eggman's bond measure to go this year?
I'll just repeat what I said before. My fellow legislators are going to be voting on this. It's double referred. It's been through the Resources Committee recently. I forget what the second committee is, but eventually it will go to the floor in the Senate and the Assembly. And since this is sort of focused more on Northern California, we really need for legislators in the South. And as I said, there are more votes south of the Tehachapies than there are north of the Tehachapies. And some of them may think they might ask the old Whiffam question, what's in it for me? And what's in it for them is helping the state entirely. So become advocates for this.
Thank you, and thank you for yours and Senator Eggman's willingness to co-author the bill. Did I get that term right? Co-author?
Joint author.
Joint author,
yeah.
Sorry. That's one step up from co-author.
Oh, it's a huge step.
Yeah, big step. Okay. All right. Time for one last question before some closing business we're going to do. Anyone have any other questions? Okay, so I'm going to ask